Welcome to the Virtual Training Institute. My name is Ellen Beattie, and you are attending the session, Making Every Math Moment Count. So I've gone ahead and asked in the chat box to use the questions box if you have questions or you want to add comments to the presentation. Unfortunately, you can only see what's in the chat box. For you to respond, you need to respond in the questions box. So I will keep that open. All right, so as we get started today, I'd like to know who we have joining us. So I'm going to launch a poll to determine who we have with us today. So go ahead and take a moment and just choose what your role is within your program. Okay, amazing. So 56% of you are ABE instructors, so that must mean that math rings a special bell to you. So thank you for joining us today. All right, let's get started. All right, so thank you for the poll. Thank you for using the questions box. My name, again, is Ellen Beattie, and I am operating out of the state office on team labor. And so I do want to offer something in full transparency, that I am a terrible math student. So my math teachers, when I was growing up and even through college, had to incorporate games and fun activities to get me to pay any attention into the math world. So today we're going to talk about a few things, and I have a couple of challenges for you. I'd like to challenge you by the end of our session to be able to describe the connection between engagement and active learning. And also, I'd like you to be able to articulate the findings of scholarly research as it relates to games. So we're going to look at what does the evidence show and what does the evidence not show in the field of using games within educational settings. I'm also going to challenge you to promote intellectual openness, curiosity, and a positive classroom, all while fostering mathematical knowledge through game-based learning. So we're going to start with two premises. The first one is on top. Active learning leads to deeper levels of student engagement. So I want to be clear that active learning is a strategy for increasing student engagement. It is certainly not the only strategy for increasing student engagement, but it's the one that we're going to talk about today. So I'm sure that I'm not sharing anything new by saying that active learning is when our students are engaged in doing something. So active learning, they are fully participating in their educational systems. You might be asking them to practice skills, to solve problems, to struggle to figure out complex questions and propose solutions. In an active learning environment, the student is taking increasing levels of responsibility for their own learning. So learners are not passive. They are not simply sitting in your classroom absorbing information by listening. Active learners are engaged learners. And student engagement refers to that intensity by which those students are applying themselves to the learning process. So the second premise that we're going to use today is that student engagement drives student learning and performance. And we're going to take a comprehensive look at engagement. So student engagement is that meaningful engagement that your students have with you, but also your staff, your instructional materials, the activities that are happening in the classroom, and your curriculum. And we can think about student engagement from three dimensions. We can think about it from the behavioral aspect. So your students' participation in the academic and learning activities that you're presenting with them. The second dimension would be an emotional attachment. So how engaged are your students emotionally with their peers, with their teachers, with your institutions? And finally, cognitive engagement. And cognitive engagement refers to how thoughtful the student is and how willing the student is to master the difficult skills that you're teaching. So the roots of student engagement lie in the research on student involvement. So if you're interested in learning more about student engagement, a great place to start is the theory of student involvement from the early 1980s. And it stressed that greater student involvement in an educational setting means the greater the student is learning and developing themselves professionally and personally. More recent research looks at engagement as an important means for students to develop feelings about their peers, their professors, and their institutions, and that gives them a sense of connectedness. We know that students who are connected, who are affiliated, who feel a sense of belonging are students who are more engaged. So the one thing that I would also really should have put on this slide is that the time and energy that students devote to their educational activities is the single best predictor of their learning and their professional development. So today we're going to talk about games. And if we connect it back to the title of this presentation, I chose games because it allows you as an instructor to make use of every available minute. So you know that those are those minutes that exist when students are arriving into class. Those 10 minutes at the end of class, when it's too late to start something new, but you don't really want to let them go yet. Or even those minutes when you're looking in their eyes, they're glazed over, and you realize that they've really reached their max. Their attention is gone from the present moment. And all of those times are perfect opportunities for you to infuse some fun, maybe some friendly competition, and framed in a perspective of learning. So as we talk about games today, I want to talk about the difference between gamification and game-based learning. I'm also just going to open up our questions so I can see. All right, excellent. Okay, so gamification and game-based learning, or GBL, they're often used interchangeably in an educational setting, but they really have two very different meanings. So gamification is the process of adding game elements to something that's not a game. So if you award points to homework activities, or somebody's giving out gold stars for completing something, that would be an example of gamification. You're adding game elements to something that is not a game. Game-based learning applies to the concept of introducing games to facilitate and amplify the actual learning process. So the difference might seem slight, but it's the outcome that produces totally different results. Game-based learning is play, but it has defined learning objectives. So generally, a game-based learning activity would be designed to balance the actual subject matter that you want them to learn, the ability to have a little bit of fun. But the point is that they can take that learning and apply it to the real world. So many of you might be familiar with completing a March Madness bracket, where you use all 16 of those teams and you dwindle them down to come up with a winner. That would be an example of gamification, because in and of itself, filling out a bracket is not a game, but they're creating excitement around it by offering prizes or points or whatever they're adding around something that's not a game. If you're thinking about math homework, an example of gamification in that way would be if you everyone who submits their assignment on time gets 5 points, and over a session, the person with the most points gets a prize or something like that. That would be gamification of regular homework assignments. If you're thinking about creating a game-based learning activity, you're actually looking at revising the actual content of the assignment to make it more game-based, to adding an element of competition um, or play between people. So two similar concepts, but wanted to take the time to just kind of talk through why, if you're looking at research or if you're looking at articles, you might see gamification, and then in other articles, you might see game-based learning, and they really are very different solely, not solely, but primarily because of that defined learning outcome and that application to the real world. All right, so let's look at the research around games. And so the research around games has been fairly plentiful in the last couple of years. And one of the reasons why is because digital games are everywhere. And there's a lot of research around how many people, youth and adults, are both playing these digital games and the sheer number of hours that they're spending in a week on digital types of games. So that concept of what people are doing in their free time begs the question, can we take something that people already enjoy, already like to spend their free time doing, can we move that back into an educational setting to help us reach our goals of learning and performance? But a word of caution before we look at some of the research. So meta-analysis studies, those are studies that look over multiple studies, help us to kind of decipher out the themes of the research. So instead of reading maybe 300 articles on game-based learning, we can read a meta-analysis or two that gives us a distilled version of what the research out there says. Those meta-analysis, when you look at them, they do have conflicting results. Some are going to show that games increase learning outcomes. Some are not going to show that. And one of the reasons why is because the word game is so vague. What you define as a game might be different than what I define as a game. And anytime that a variable has that kind of subjectivity, it makes the research a little bit harder. So let's go on to see what the research actually says. And I picked out three key elements that I wanted you to share, or that I wanted you to take away. The first is around academic performance. There are a large number of quantitative studies that show a moderate advantage for games over other instructional approaches in fostering knowledge, specifically in science, mathematics, and literacy. Those same studies talk about games as productive habits of the mind. So they have a better opportunity than other instructional approaches to fostering things in our learners like intellectual openness, curiosity, conscientiousness, and a positive self-approach to learning. The other aspect is that games provide a very easy way to adapt to specific learner characteristics. So to be adaptive in the capacity of a game means that you can engage learners in a way that is specific to their situation. So maybe you're tailoring your games to their level of cognitive abilities or their level of previous knowledge about a subject, or maybe even to their emotions or other factors that make them unique. And it's this type of modification of the type and the complexity of the problems and the guidance that's presented to the learners that is what increases the engagement. And this last one is my favorite one, graceful failure. Game-based learning is effective because it allows for graceful failure, which might be my new tagline of 2020. Rather than describing failure as this undesirable outcome, failure within a game setting is just a normal part of the process. And when we lower the consequences of failure, It encourages our students to do things like take risks or to be more open to new experiences, to be open to exploration. So that when we are allowing our students to put themselves into situations where they can fail, they realize that failure is not as final as sometimes it can feel. That is a fantastic skill to transfer out to other settings. So you'll see that the neuroscience of games is not included in my research findings. That would be another presentation that we certainly could not fit into 30 minutes. But what I will say, because neuroscience is one of my favorite topics, neuroscience of learning, is that our brains love to predict the future. So games are very well connected to our brain's ability to predict and then engage the reward perspective of the reward complex neurochemicals in our brains. So it's a great way to engage our brains in a different way around the academic content that we want students to learn. There's also an emotional aspect that comes with game playing and a social aspect that comes with game playing. And both of those things are very well documented in the neuroscience research of learning. All right, so I'm going to leave you with the research component of our time together with this slide, that action changes things. By action, we're talking about active learning, and when we're talking about changing things, we're talking about changing learner performance, learner outcomes, and all the things that we as educators want to see. So I am going to introduce you to my favorite math game. So again, full transparency, I was introduced to this game by my favorite math teacher, my dad. This is Krypto. And go ahead and type in the questions box if you've ever played Krypto or ever heard of Krypto. This is what the box looks like. Hopefully you can see that. So Krypto is a card game, and it's not a new card game. The card game originated in 1963. So it's been around. Oh, awesome. People have not heard or played of this game. All right, fantastic. Well, you're going to play today because the second half of our session is game playing. All right, so it's a card game. 1963 was put out by Parker Brothers, and it's a crypto card deck. Okay, so this is what the deck looks like. 56 cards. Okay, there's 3 of each number, 1 through 6. There's 2 of 11 to 17, and there's 1 of 18 to 25. So you have to use all of the cards once. So in the next slide, this is going to become a little bit more clear. What you would do is you would, of course, shuffle your card. And then what we're going to do is, here, let's just go to the next slide. You'll be able to see. All right, so here's the great thing about this game. You can pre-plan it if you don't have this group of cards, but I will say that I got this on Amazon because I couldn't find my original copy downstairs. So $10.99, a fantastic use of Amazon Prime, got this to me. I ordered it on Saturday. It's here already. So, so you get 5 playing cards. And so in this example, we're going to use these cards, 1, 2, 3, 4, and 5. And there's probably no way you could ever actually use this deck and come up with those, but we're going to use them for right now. So you can use any of the mathematical operations that you need to, adding, subtracting, multiplying, dividing. You have to use each of these cards one time, and you need to get to the number 15. So this game is super adaptable because you can choose the level. Okay, so for our first time, I just chose that randomly. So can anyone see a way that you can use 1, 2, 3, 4, and 5 Okay, Jeannie, add all the cards. Right. So if you add 1 and 2 and 3 and 4 and 5, you get to 15. Now, the great thing about Krypto is that the solution that one person sees is hardly ever the solution that a second person sees. So someone else might have another solution to get to 15 using those same cards. So like I said, it's super adaptable. For your lower level math learners, you could just use the 1 through 10 cards. That would be a way to take the math level down 1. For your more advanced learners, use all, all 56 to 25. So you have a general idea of how we're going to play this? So the question that arises a lot is, can you use the product of the cards? So in this example, if I am using 4 plus 8 and getting 12, and then I'm adding the 9 and the 1 card to get 10, all of a sudden I have 22. And then if I subtract the 3, the last card there, then I can get to my 19. All right, so you can do that. You can, I don't know, there's probably a mathematical term that you guys know that I probably don't, about how you can group those together and then come up with the answer. All right, so let's see. Kathleen is saying 2 times 3 plus 5 plus 4 plus 1 would also give you that let's go back one, would also give you the 15, right? So that's what's fun about it, right? Because what I see as a very quick path in my mind is maybe very different than what you see. And that's the fun of it. And so that's one of the keys to this game, right? That it teaches students. There's not one right way to get to the answer. And just like in life, there's not normally just one path to success. Okay, so so does anybody have another way to get to this one, to get to 19? Remember that you have to use each one of the cards and you have to use it only once. Okay, this reminds Holly of a bit of the 24 game. I don't even know that game. Another similar game is 4 fours from U cubed. Okay, thanks. Excellent. Excellent ideas. Okay, so let's try one that we actually pick from the deck, because I am really confident in your math abilities. Okay, so everybody ready? Pen out. All right, here we go. 8, 12, 17, 4, 17. All right, and our goal card is going to be 22. Okay, so let me put these in the chat. "12, 17, 4, and 17. Our goal is to hit the number 22. So take a few minutes with your piece of paper and your pencil or just your mind, and see if you can use 8, 12, 17, 4, and 17 to get to this card, 22. Oh, Carolyn, 17 plus 17 is 34, minus 12 is 22. Okay, so did you use all the cards? You used 17 and 17 minus the 12. Oh, but you still have to do something with the 4 and the 8. Very close, Carolyn. Okay, Susan, let's see what you have here. You've got 12 times 4 is 48. And then 48 minus 17 minus the other 17 is 14. And then 14 plus 8 is 22. Susan, nice job. Nice job. And Jennifer. Okay, Jennifer, very similar. Excellent. 12 times 4, the 48, minus both 17s equals 14, minus plus the 8. Excellent. Yeah. Go Susan, go Jennifer. Excellent. All right. So I love Krypto. Like I said, $10.99 on Amazon. But it's fantastic for fostering problem solving of this for our students. It makes the learning fun. Like, look how much math that they're doing. It teaches them that there's not just one solution, teaches them to think critically. What did they use last time that they can build off of next time? Teaches them to be creative with their options. And really, when they start to find the solutions, it really increases their confidence levels incredibly. So there are certainly other options of games. There are easy Sudoku puzzles out there that students can use. You know, the math crossword puzzles have been around for a long time. And all of those really have the same kinds of benefits, right? It puts fun into the learning. It creates that game-based learning that we know our students have fun with, and the research suggests that it's a good way to learn math content. It certainly helps them to be more comfortable with numbers, and just the fact that it's a card game makes it fun for a lot of people. So I'm going to leave you with the same slide that action changes things. I would highly encourage you to consider the use of games and to use them in those times when you just have those few moments that maybe energy is low in your classroom. You can use them to raise the energy, raise the confidence of your students, and really put some fun back in learning. So I'm also going to give you one extra thing. So I don't need this Krypto game because I have one downstairs that I just need to find. So I'm going to give you one more set of Krypto cards, and the first person who emails me or posts on our MD Adult Ed hashtag, I will send you this Krypto game. So let's see. We're going to use 5, 2. I'll type them in the chat box. 5, 2, 18, 13, and 3. And our goal is going to be 7. So I'll give you a couple minutes to write those down, and I'll respond verbally in case you can't see the chat box. 5, 2, 18, 13, 3. Those are the 5 playing cards, and we're trying to get to 7. All right, team, it's been a wonderful half hour spending with you. What I'm going to do very quickly is find our link for feedback. This is our very second. Sorry, I can't actually type links and talk at the same time. This is our second virtual training institute. And in the spirit of continuous improvement, we would love to get your feedback on how we could improve it to provide better professional development for you in the field. So thank you so much. Please take those Krypto cards, Krypto numbers down, and shoot me an email. Or if anyone's like a really big math rock star, you can do it now. And this Krypto game will go to the first person who gets a answer, because we know there's probably more than one. I'm looking through the questions. Do you have any digital games for math learners? And then math games at a distance. What ideas do you have for virtual classrooms? I think you could use this in a virtual classroom, just very similar to how we did it. And if you could see people, like if you were using a platform where you can actually see people, because I can't see you, that would make it even more fun. But yes, so I have a handout that will have some easy Krypto hands if you want to try it with your lower level students. And I also have like a sheet that you can print out to get all of these. So if you don't want to go out and buy the game from Amazon, you can make your own. And you can certainly use that in the digital world. So thank you so much for your time, guys. I really appreciate being able to share Krypto with you. My dad would be proud to know that I was sharing the game. And actually, I don't even know why he's not on here. But so thank you so much for your time today. And we will see you. We have a 5 o'clock session tonight. And we have a full day of learning tomorrow. So we can't wait to see you back here. All right, have a great afternoon.